I am going to start the fifth module. Here we have three parts. One is the continuation of fourth module, that is multi-step solution of ordinary differential equation. This is first part, where we have two methods actually. One is Milne's method, Milne's predictor character method. Okay, means actually it is a combination of two methods. One method is used to predict the value, that is initial value. Then the second method is used to correct the value. So one method is a direct method and second one is the iterative method. Character is the iterative method. Similarly, we have Adam's method. Okay, Adam's predictor character method or Adam's backforth method. Okay, where one method is used to predict the value and second method is used to correct the value. Okay, so these are two important multi-step methods in fifth module to solve ordinary differential equation. So this is part A. Now part B is boundary value problem. Okay, so boundary value problem means we have the differential equation like y double dash plus f of x into y dash plus g of x into y equal to r of x. Please note y double dash plus f of x into y dash plus g of x into y equal to r of x. With the two boundaries, that is y of x0 equal to y0 and y of xn is equal to yn. So two boundaries of these things are given and we are asked to find the intermediate of y0 and yn. We are asked to find y1, y2, y3 etc. up to yn minus 1. So that one is boundary value problem. So this one is the second part of fifth module. And third part is the solution of partial differential equation. Solution of partial differential equation. Okay. So actually three parts are there in partial differential equation. One is Laplace equation. Okay. Second one is verb equation. Third one is heat equation. Okay. So in fifth module we are going to discuss about Milne's method, Adam's predictor character method. Actually 1 day or maximum 2 days solution for this. Then boundary value problem. So actually 2 days of solution for boundary value problem. There is no methods how to solve it. That's all. There is no different types of methods that is not available for boundary value problem. How to solve it iteratively. That is boundary value problem. By using direct method also we can solve boundary value problem. So here I am saying about direct method and iterative method means the methods that is used to solve the linear system like Gaussian elimination method, Gauss-Jordan method. These two are the direct methods. Similarly, Jacobi method or Gauss-Seidel method. These are the iterative methods. So these methods can be used to solve boundary value problem and also the partial differential equation problem. Okay. So please note part B and part C of fifth module are the solution point of view. Approach point of view, part B and part C are almost similar. Okay, with a slight difference. Okay. Now, so we are going to discuss about boundary value problem, and in part C, partial differential equation, we are going to discuss about Laplace equation. The wave equation and heat equation are not included in the syllabus. Okay, so we have to discuss about 4 different topics. So any doubt? So these are the things that we are going to discuss in fifth module. Any doubt? Okay. So first we are going to start the discussion about partial differential equation. Before going to discuss about partial differential equation and also boundary value problem, we need some assumptions, we need some basics, or we need some tools to solve this boundary value problem and partial differential equation. So first we are going to discuss about those tools. Those tools are nothing but how to approximate or how to replace a differential term with points, data. How to replace differential equation with data or different term. How to do that? Okay. So that we are going to discuss. Okay. So first take the first order differential term, that is dy by dx. How to replace this dy by dx? Then we will discuss about how to replace d square by ds square. Okay. So for convenience, instead of dy by dx, for a time being, we can write du by dx. Similarly, du by dy. Okay, because for partial differential equation we have a function that is depending upon both x and y. So we need two different terms. So how to represent du by dx and du by dy? Or similarly, how to represent d square u by dx square and d square u by dy square? So that we are going to discuss. Okay. So first one, how to represent the differential term using forward difference approximation. Forward difference approximation. Okay. So that is the first thing we are going to discuss. So say we have a function u with respect to x. We have a function u with respect to x. Then what is u of x plus h as per Taylor series? What is u of x plus h as per Taylor series? U of x plus h is a new point after x, and we are asked about the value of u corresponding to x plus h. We have a function u of x, that one is a function. Now if you are asked to find a value of u corresponding to x plus h, അത് എങ്ങനെ ട്രേഡേഴ്സ് മെത്തേഡ് വെച്ചിട്ട് നമുക്ക് കണ്ടുപിടിക്കാം എന്നതാണ് ചോദ്യം. So please note, in this particular case, if x is a point and h is a variable, how can we write this? We can write it as u of x plus h into du by dx plus h square by 2 factorial into d square u by dx square plus h cube by 3 factorial into d square u d cube u by dx cube plus x cube. Please note, u of x is a function, so we can write u of x plus h, the next point of x, is equal to u of x plus h into du by dx plus x square by 2 factorial into d square u by dx square plus h cube by 3 factorial into d cube u by dx cube plus h square. So we can write it as equation number 1. We can write it as equation number 1. It's an infinite series, അല്ലേ? ഇത് ഒരു ഇൻഫിനിറ്റ് സീരീസ് ആണ്. അപ്പോൾ നമ്മൾ ആവശ്യാനുസരണം നമ്മൾ ഇതിനെ ടെർമിനേറ്റ് ചെയ്യും. So if I am terminating at this particular point, ഈ പോയിന്റ് ടെർമിനേറ്റ് ചെയ്യുകയാണെങ്കിൽ what we can write? We can write u of x plus h is equal to u of x plus h into du by dx. We can write u of x plus h, the next point of x, is equal to the current point of x, u of x plus h into du by dx. So this one is a terminated one. So actually it is almost equal because it's terminated. So from this equation, I can write du by dx is equal to u of x plus h minus u of x divided by h. Any mistake? I can write du by dx is equal to u of x plus h minus u of x divided by h. Is it clear, all of you? That is u of x plus h is equal to, as per Taylor's method, it is u of x plus h into du by dx plus h square by 2 factorial into d square u by ds square plus h cube by 3 factorial into d cube u by dx cube plus etc. So that is equation number 1. So if you are terminating at this particular point, means if you are removing these remaining terms, then we have u of x plus h is almost equal to u of x plus h into du by dx. We can write du by dx is equal to u of x plus h minus u of x divided by h. We can write du by dx is equal to, we can write the next position of x as ui plus 1 minus, we can write the current position of u as ui divided by h, where ui is equal to u of x or u of xi and ui plus 1 is equal to u of x plus h. So this is nothing but the forward difference approximation of du by dx. This one is the forward difference approximation of du by dx. So please note, first we have Taylor series expansion of u of x plus h, that is equation number 1. Then that one is terminated at this point. So we have u of x plus h is equal to u of x plus h into du by dx. So we can elaborate as equation number 2. Now this one is modified as du by dx equal to u of x plus h minus u of x divided by h. I told you u of x plus h is the value of u corresponding to the next point of x, that is x plus h. U of x is the value of u at the current position, that is u of x divided by x. So this one is du by dx after modifying equation number 2. So if you are labeling the current position as ui and the next position as ui plus 1, then we can write du by dx is equal to ui plus 1 minus ui divided by h, where h is the period of this letter. So please note, this one is a valid term because this is actually this is almost equal to, but we can write it as equal to. This is a valid term because if h tends to 0, you can see that this right hand side is nothing but differentiation if h tends to 0. So please note, this one is forward difference approximation of du by dx. So next one is backward approximation. So in backward approximation, again say you have a function u of x, but here we are going to find the previous one. If x is the current position and h is the period, then the previous value is u of x minus h. And can anyone expand this u of x minus h as per Taylor's method? Can you write the Taylor series expansion of u of x minus h? Can anyone? U of x minus h in there. Taylor series expansion പറയും.
Sir, alternate ആയിട്ട് പ്ലസ് മൈനസ് വരുന്ന.
Exactly. So this is equal to u of x minus h into du by dx plus h square by 2 factorial into d square u by dx square minus h cube by 3 factorial into d cube u by dx cube plus etc. So this is equation number 3. So please note, this is previous point, that is backward. We are going to back side. In previous slide, we move to forward side, which we determine the next one, that is u of x plus x. Now we have u of x minus x. So that is equal to u of x minus h into du by dx plus x square by 2 factorial into d square u by dx square minus h cube by 3 factorial into d cube u by dx cube plus etc. So this is equation number 3. Okay. So now, like the previous slide, we are going to terminate after this first order, which we are going to remove the second order and higher order terms. So after this we are going to terminate. We are going to remove. So what we can write? We can write u of x minus h is equal to u of x minus h into du by dx. U of x minus h is equal to u of x minus h into du by dx. So note it as equation number 4. Note it as equation number 4. Okay. So from this equation number 4, what is du by dx? So please tell me, what is du by dx from this equation number 4? This is almost equal to, because that is truncated. So what is du by dx?
U of x minus u of x minus h by h.
Very good, very good. So here du by dx is equal to u of x minus u of x minus h divided by h. So this is du by dx, where u of x is the current point, u of x minus h is the previous point, divided by h. So I am repeating, u of x is the current point, u of x minus h is the previous point. So we can replace it as, with respect to the data position, we can write this equation as du by dx is equal to ui minus ui minus 1 divided by h. Okay. So du by dx is equal to ui minus ui minus 1 divided by h. Okay. Where ui is nothing but u of x, and similarly u of I minus 1 is u of x minus h. So this representation is known as backward difference approximation of du by dx. Backward difference approximation of du by dx. Is it okay, all of you?
Yes, sir.
So please note all these equations. Once again, we need these equations also. So please note. So I am repeating that equations for forward difference approximation. We expanded u of x plus h, that is equal to u of x plus h into du by dx plus h square by 2 factorial into d square u by dx square plus etc. So we noted it as equation number 1. So from this we terminated truncated the series after this point. So we have u of x plus h is equal to u of x plus h into du by dx. So this one is noted as equation number 2. So from this equation we derive du by dx is equal to u I plus 1 minus ui divided by h. Okay, so this is forward difference approximation. Similarly, we expanded u of x minus h, that is equal to u of x minus h into du by dx plus h square by 2 factorial into d square u by dx square minus etc. So this is equation number 3. Now we truncated up after this point. So we have u of x minus h is equal to u of x minus h into du by dx. So from this we can write du by dx is equal to ui minus ui minus 1 divided by h. So this is backward difference approximation. So now we can write what is equation number 2, what is equation number 2 minus equation number 4. My question is, what is equation number 2 minus equation number 4? This is equation number 2, that is u of x plus h equal to u of x plus h into du by dx, and this is equation number 4, that is u of x minus h is equal to u of x minus h into du by dx. So my question is, what is equation number 2 minus equation number 4? That is u of x plus h minus u of x minus h. So that is left hand side, u of x plus h minus u of x minus h. Now right hand side you can see that this u of x and this u of x are cancelled. Now what is remaining? The remaining term is 2h du by dx. 2h du by dx. Am I correct? All of you? If you are taking the difference between equation number 2 and equation number 4, we have u of x plus h minus u of x minus h is equal to 2h into du by dx. So this is equation number 5. This is equation number 5. So from this we can write du by dx is equal to u of x plus h minus u of x minus h divided by 2h. We can write du by dx is equal to u of x plus h minus u of x minus h divided by 2h, where u of x plus h is the next point of u of x, and similarly u of x minus h is the previous point of u of x. So we can write du by dx is equal to the next point, we can write it as ui plus 1 minus the previous point can be written as u of I minus 1 divided by 2h. So what is the thing? Next point minus previous point. Apply number discuss it. Next point minus previous point. It is nothing but
Central.
Yes, exactly. This is nothing but central difference approximation. Central difference approximation. Okay, this is also known as finite difference approximation. Finite difference approximation. Normally, we are going to use this equation. In order to solve the boundary value problem and the Laplace equation, we are going to use this central difference approximation. Okay, because that is more convenient. Okay. If it is not applicable, then we have to use forward difference approximation or backward difference approximation. Normally, we are using central difference approximation. Okay. So how we derived this one? We took the difference between equation number 2 and equation number 4. One more method is to derive this one. Just take the average of these two terms. Take the average of this equation and this equation. If you are taking the average of these two equations, we have du by dx is equal to ui plus 1 minus ui minus 1 divided by 2h. Okay. So please note, we discussed about three different types of representation of du by dx. If it is forward difference approximation, we have du by dx is equal to ui plus 1 minus ui divided by h. If it is backward difference approximation, it is du by dx is equal to ui minus 1 divided by h. And if it is central difference approximation, it is du by dx is equal to ui plus 1 minus ui minus 1 divided by 2h. Okay, so three different representations, and I told you we are going to use normally this equation. Okay, so this is very important. This is very important. So please note down the right hand side equations. So now we are going to consider these two equations again. Okay. What is these two equations? One is the Taylor series expansion of next point, that is u of x plus h equal to u of x plus h into du by dx plus h square by 2 factorial into d square u by dx square plus etc. And second one is the Taylor series expansion of previous point, that is u of x minus h is equal to u of x minus h into du by dx plus h square by 2 factorial into d square u by dx square plus minus etc. Now add equation number 1 and 2. What we have? Please tell me. Just add equation number 1 and 2. What we have? If you are adding equation number 1 and 2, left hand side we have u of x plus h plus u of x minus h. U of x plus h plus u of x minus h. This is left hand side. Now what about right hand side? You can see that these two equations have u of x. So if you are adding these two together, we have 2 into u of x. Now this first equation have h into du by dx, and second equation have minus h into du by dx. So these two terms are cancelled. Now these two equations have h square by 2 factorial into d square u by ds square. These two equations. So it will become 2 into h square by 2 factorial into d square u by dx square. Now definitely the next term are cancelled. This is plus h cube by 3 factorial into d cube u by dx cube, and this is minus h cube by 3 factorial into d cube u by dx. But that is not important for us, so I am simply writing plus x cube. The remaining terms are not important. Okay, so I am writing the sum of the addition of equation number 1 and equation number 3 as u of x plus h plus u of x minus h is equal to 2 into u of x plus 2h square by 2 factorial into d square u by dx square plus x. So I am noting it as equation number 7. Equation number 7. Okay. So now for convenience, derive this term, I am going to terminate this equation at this particular point. Okay, so I can write u of x plus h plus u of x minus h is equal to 2 into u of x plus, now here you can see that this 2 and denominator 2 are cancelled, so we have x square into d square u by dx square. So this is equation number 8. U of x plus h plus u of x minus h is equal to 2 into u of x plus h square into d square u by d square. So from this, what is d square u by d square? Equal to what? We can write it as u of x plus h minus 2u of x plus u of x minus h divided by h square. D square u by d square is equal to u of x plus h minus 2 into u of x plus u of x minus h divided by h square. So this one is the functional representation where u of x plus h is the next value of x, u of x is the current value and u of x minus h is the previous one. So data point of view, we can replace this equation as d square u by dx square is equal to ui plus 1 minus 2ui plus ui minus 1 divided by h square. So this one is the finite difference representation of d square u by ds square, or this one is the center difference approximation of d square u by dx square. Okay. So please note all these equations. In boundary value problem, we can see functions like y of x and s. So at that point, we need dy by dx and d square y by dx square, where dy by dx can be written as by using center difference approximation yi plus 1 minus yi minus 1 divided by 2h, and similarly d square y by dx square we can write it as yi plus 1 minus 2yi plus yi minus 1 divided by h square. Okay, so please note there is no need to worry about this thing. It is depending upon what is there in numerator and denominator. Okay, if it is a single variable function, then normally in numerator y is used to represent function. So dy by dx is equal to yi plus 1 minus yi minus 1 divided by 2, right? And here d square y by dx square is equal to yi plus 1 minus 2yi plus yi minus 1 divided by h square. So this one is about single variable function. But for partial differential equation or Laplace equation, it is a two variable function. It have two variables. Okay, two variable means we have two coordinates for independent variable. One is x and second one is y. These two are independent variables. Okay. Now we have a third coordinate that is used to represent u, which one is a dependent variable. This one is a third coordinate that is used to represent the dependent variable, where u is a function of x and y, u of x comma y. So normally, no matter point of view, it is better to represent the function u of x comma y in a two coordinate system. We can use two coordinate system, means we have function u of xy that is depending upon both x and y. So here the values of u of x comma y are marked here. Say at this particular point value of u is u of x1 comma y1. At this point the value of u is u of x2 comma y1. At this point value of u is u of x3 comma y4, something like that. So what we are doing? We are representing a two variable function using two coordinate system, using points or mapping. We are mapping the function into a two coordinate independent variable system. Okay. So this is not important for us. Number derivation is important enough. Okay. So what I am trying to say is, if u is depending upon both x and y, then we can see the terms like du by dx, d square u by ds square. Similarly, we can see du by dy and d square u by dy square. We can see normally four different terms. Okay. We can also see d square u by dx dy. That also we can see. Okay. But for our discussion, we are not dealing with this particular term. So we are not considering that particular term. So for our discussion, we can see four different terms: du by dx, d square u by ds square, du by dy, d square u by dy square. These four terms. So we have to know how to represent all these four terms using the finite difference approximation. We have to see. We already derived du by dx and d square u by ds square. And what are those representations? Those representations are du by dx is equal to ui plus 1 minus ui minus 1 divided by 2h. This is the finite difference representation of du by dx. Similarly, we can write d square u by dx square is equal to ui plus 1 minus 2ui plus ui minus 1 divided by h square. Okay. So please note, what is I, what is h? What is I? So here I told you this term is u of x1 comma y1. And what about this term? This term is u of x2 comma y1. Why? Because throughout this line y is constant, y is not changing. So the y representation is y1. For these 2 points, y1 is y1. What about, so this is y1. What about x? This is x1, this is x2. So actually what is I here? I is used to represent the x values. This is here I equal to 1, here I equal to 2. Means here I is varying. Here I is varying. The first value of x is x1, second value of x is x2, third value of x is x3, etc. Similarly, the difference between the adjacent x value is h. The difference between the adjacent x value is h. The difference between the adjacent x value is h. Similarly, we can represent y value also. This one is the first value of y, that is y1. This is second value of y, that is y2. This is third value of y, that is y3, etc. So I can't use I here, because the I in order x in order use it. So I can use j here. So j is used to represent the position of y values. The first j position is 1, that is y1, then j equal to 2, then j equal to 3, like that way it will go. Okay. Similarly, the difference between the adjacent y value, we can use k to represent the difference between the adjacent y value, that is y2 minus y1 equal to k, y3 minus y2 equal to k, etc. So please note, x2 minus x1 equal to h. Similarly, y2 minus y1 is equal to k. Means h is the period of x and k is the period of y. Any doubt? ഇതുവരെ എന്തെങ്കിലും കൺഫ്യൂഷൻ വന്നോ? ശ്രദ്ധിക്കുക, രണ്ട് കാര്യങ്ങളാണ് ഞാൻ പറഞ്ഞത്. x values represent x നെ ഇൻഡെക്സിനെ റെപ്രസെന്റ് ചെയ്യാൻ I യൂസ് ചെയ്തു. Where I is varying from, so please note, I is used to represent x, or that is x index. Okay. and it is from 1 to we can write it as m, 1 to m. The first one is x1 and the last value is x, and period of x is h. Now j is used to represent y values, means there is a y index. J is the y index, and that is from 1 to n. That is from 1 to n. And period of y is k. So k is used to represent the period of k. Now go through this du by dx and d square u by d square. What is the index of u? If denominator is x, the index of u is I plus 1, I minus 1, I etc. When if denominator is dx. Here also you can see that the denominator is d square, that is x. X is available in the denominator. So what about the index? You can see that I plus 1, I minus 1. Is it okay? Second thing is the denominator is x. So you can see that the period term is h, or here period term is h square. Now please say what is du by dy. Please say what is du by dy. എന്തായിരിക്കാം du by dy? Please note, in du by dy, the independent variable is y, and the index of y is j. J is the index of y. Okay. Now what we can write? This is first order term. So the first order finite difference approximation of first order term is u. Now what about index? We have to use j. So j plus 1 minus u j minus 1 divided by 2 into, now what is period? If it is y, period is k. So du by dy is equal to u j plus 1 minus u j minus 1 divided by 2k. Similarly, what is d square u by dy square? Please tell me. What is d square u by dy square?
uj plus 1
Okay.
minus 2j
To u
uj minus
divided by
k square.
very good, very good, very good. U j plus 1 minus u j, minus 2 u j plus u j minus 1 divided by k square. Okay, so please note all these four terms. Now we are going to use these four terms to solve Laplace equation. Laplace equation means partial differential equation. Okay, du by dx equal to ui plus 1 minus ui minus 1 divided by 2h. D square u by dx square equal to ui plus 1 minus 2ui plus ui minus 1 divided by x square. Du by dy is equal to uj plus 1 minus uj minus 1 divided by 2k. Similarly, d square u by dy square is equal to uj plus 1 minus 2uj plus uj minus 1 divided by k square. Okay, so please note.